So we'll review real quick how we ended yesterday's lesson. We were looking at balancing chemical reactions, or chemical equations rather. The ultimate goal with this balancing is to make sure that on both sides of whatever chemical equation you're working with, you have the same number of each kind of atom. I gave you some tips on the bottom to get you started. Some of them will be useful, you'll use them forever. Some of them, as you get more comfortable with this stuff, you'll drop and you might pick up other tips. This is really quite a growing skill. It doesn't have the same hard and fast rules that the formula writing does, that the naming does. Those are rules written in stone. You have to follow. Everyone who does chemistry anywhere does. But what we're going to look at now is really, you'll start to develop some of your own techniques as you practice this further. So I'm going to do a bunch of examples, and then I'm going to free you, and I'm going to ask you to move to the whiteboards to work through these. So here we go. The tips that I gave you, because balancing involves some trial and error, I encourage you to use pencil or whiteboard pen on whiteboard, which I'm going to force you to later today. Usually we're going to start with the furthest left element, work your way right. If oxygen and hydrogen show up in several different formulas, we're going to leave them to the end. Hydrogen is almost always the absolute last thing you're going to balance. I put a star here to come back to this tip. We may not, depending on who wants to see it. And you know what? I will show it to you. And you can choose whether or not you want to use it. And then this last tip here is, if odd amounts of oxygen cause problems, double everything you've done. And so here, let's do a couple examples and show you what I mean. Okay, here we go. So this first one looks very similar to the one that we've already done, but it's nice to start somewhere familiar, so let's go ahead and do it. When you're balancing these things, the way I always teach it is from that arrow in the middle, draw a line down the page to separate the products from the reactants. And then on each side, the reactant side and the product side, write down every individual element that you've got. Don't write it down more than once, even if it shows up in multiple spots on the same side. Just write it down once. So I've got K's and I've got O's on both sides. And now before we do any balancing, let's just count, see what we've got, see where the problem is. I've got one potassium on the left when there's no subscript, when there's no coefficient. Both of those empty voids have ones, and so 1 times 1 is 1. And on the left-hand side, I've got 2 oxygens. On the right-hand side, I've got a subscript 2 on the K, which tells me I've got 2 potassiums. And there's nothing written next to the O, so I've only got one of those. So neither of those atoms are balanced. We have to go ahead and make sure that happens. Now, one of the first things I told you was to start on the left and work your way to the right. It's a bit of a bummer that this is the first example, because you're going to see that that's actually a really bad idea on this one, but we're going to do it anyway. So let's start with the thing on the left, because that was the first tip that I gave you. Let's balance the potassiums. Now, if you recall, the only thing that we're actually allowed to change is the coefficients out front. I can't separate elements within a compound. They are built the way they're built. I cannot add coefficients. I cannot add subscripts. The only thing I can change are coefficients. So what could I put out in front of the K so that I have the same amount of potassium on both sides? I've got 2 over here. There's no subscript written, so this is going to show up in groups of 1, and I need 2 of them. What number could I put there? I put a 2 there. If I do that, I put the 2 there, now I recount everything. Putting a 2 out front gives me 2 potassiums, and oh look, I have 2 potassiums on the right, we're good. So now we're going to move, we're going to look at the oxygens. One of the things that I told you that you're usually going to leave to the end. So I've got 2 oxygens on the left-hand side. I've got 1 oxygen on the right-hand side. I cannot split up the K2O. It was built, an ionic compound. It was built by balancing the charges on the potassiums and on the oxygen, so I have to change the coefficient up front. What could I put there so that I have the same amount of oxygens here as I do here? Masi says to add a 2. If I do that, if I put a 2 there, what does that do to the oxygens? Well, I've got K2O, and every group of K2O has 1 oxygen, so if I put a 2 out front here, 2 times the 1 oxygen is going to give me 2 oxygens. That's great, but what has it done to the potassiums? It's doubled it. Now I've got 4. So my oxygens are good. Now I have to go back and I have to redo the potassiums. I don't want to change what's here, so I'm going to jump back to the other side. What could I do to the Ks so that instead of bringing 2, I have 4 brought? Sorry? Yeah, and I can replace this 2 with a 4. And so now let's recount, first of all. By changing this 2 into a 4, I don't have 2 potassiums anymore. How many do I have? I have 4. And so now I've got 4 potassiums on the left, I've got 4 potassiums on the right, I've got 2 oxygens on the left, I've got 2 oxygens on the right. So now this is done, and then to write it neatly as a good copy, 4K plus O2 gives me 2 K2O. Now perhaps you can see what would have happened if I'd started with the oxygens instead. If I'd started with the oxygens instead, I would have started by putting a 2 here. That would have changed the number of Ks to start, and then I would have just jumped back to the other side and I would have put a 4 here. It would have left me with less work to do, but as a general rule, you want to avoid starting with the oxygens, even though sometimes it is actually the better idea. As you practice more of these, you'll see why starting with the oxygens is a horrendous idea. Yes? Here? Where did this 4 go? So, okay, good question. And sometimes the methods can, I want to make sure I'm answering the question properly. Everything I'm doing below the equation itself is just keeping a running tally of what's there. Like I'm not doing any multiplying down here. I'm just, every time I change a number up top, I'm just recounting everything I've got on both sides. So this K2O, what's here isn't going to be impacted by what's going on down here. When I change a number up here, I'm not multiplying these values, I'm just recounting everything that's here. Is that answering your question? I feel like I'm not. Yeah, so putting the coefficient there, putting the 2 here, says that in order for, so the reason I put the 2 here is because the oxygens were out of balance. Yes. Yes, I have 2 groups of K2. Yes, yes. This is going to take some getting used to. I'll be honest with you, it is a difficult thing to teach just because there is no, like, students like this in math. They want a hard and fast rule. When this, do this. When this, do this. And in balancing, you don't get that. There's lots of trial and error. There's lots of, you're going to develop your own techniques. You're going to learn how to see these things. And so the best I can do is expose you to a few good examples of some of the kind of ridiculous things that can show up, and then let you practice on your own or in groups of 2 or 3, and then work with every single one of you individually. Because that's really what I have to do. I have a whole bunch of techniques. I've been doing, how old are you guys? 15? I've been doing this longer than you've been alive, and so I've got your lifetime's worth of practice doing this. And so now I have to figure out, for every one of you individually, what techniques and tricks are going to work best for you. Which is why we're going to spend a bunch of time over the next couple days You guys up on the board, and I'm going to circulate. Sahib's not here today. He's doing some sport keeping stuff, but he's here too. And he's, yeah, quite capable of this stuff as well. So, number 2, same idea. The start is the same every time. When you write them out on your own, so maybe I'll say it this way. On these guys, these balancing examples, I've given you space to work with, to play with the coefficients. On the questions I'm going to assign today, I give you space to work with. But on some of the stuff that we're going to do next week, I don't give you a ton of space. These are all balancing questions, and you have no room to do any work. So when you go and you copy these things over to where you are going to do your work, the whiteboard or some blank paper, put in these blanks as they're written, because that's where you're going to start to insert these coefficients. So that's going to be there, just so you guys get used to seeing what you're going to see. These blanks are going to show up out front here. Here we go. On each side of the line that I've drawn down from the arrow that separates the reactants from the products, I'm going to write down each element that's present. I'm not going to write it down more than once. So for example, O's show up on that left-hand side, oxygens show up in 2 places. I'm not going to write oxygen more than once on the left-hand side. I'm just listing every individual element that shows up. So I'm writing down SN, I'm writing down N, I'm writing down O, I'm writing down K, I'm writing down P, and I've already written down the O. I'm not going to write it down again on the left-hand side. To make your life easy, I'm not going to go through the list again on the right-hand side. Law of conservation of mass says if it shows up on the left, it has to show up on the right. So I'm just going to write down the same list of elements in the exact same order on the right-hand side. And now, I haven't done anything yet. I'm going to start to count what's there. SN, how many tins are there on the left-hand side? Is it 1 or is it 4? Why is it 1, Massey? Hold on. Massey, why do you say it's 1? You can't explain it, but you know you're right. Massey is right. Okay? Someone who knows why Massey's right, explain it to me with all of the English you have available to you. Jedediah, why is Massey right?
I know it's right.
Brooklyn, do you know why? I heard you trying to argue with Evelyn. Yes.
Really?
Yes. So Evelyn, the reason you said 4 is because you saw this 4 right here, right? What you guys need to remember is that when you got the subscripts only apply to what is immediately next to it. So this 4 only applies to what's inside those brackets, just like that 2 there only applies to the oxygen. So because there's no number between, so Massey, here's how you would explain it. Because there's no number written between the SN and that bracket, that subscript in there would be a 1. And if we wanted to go back, I could show like Brooklyn's explanation, like SN would have to have a charge of +4, NO2 is going to have a charge of -1. I'm swapping and I'm dropping to build this. So I've got 1 tin there. How many N's do I have on the left-hand side? I've got 1 inside those brackets, but I've got a 4 on the outside of those brackets. So that 4 on the outside of the bracket says I have 4 groups of NO2. You're right, Evelyn, to say that there's only 1 nitrogen inside those brackets, but that 4 outside means how many nitrogens do I have total? You multiply it, just like we did with the counting practice yesterday. It's 4 nitrogens. Why do we have 12 oxygens, Evelyn? Perfect. 4 times 2 is 8 oxygens here, and I've got 4 more oxygens there. 8 plus 4 is 12. Perfect. How many Ks are there? This is really just an exercise in counting. It's going to be super irritating. How many Ks are there? Yes, Brooklyn says there's 3. How many phosphoruses are there? 1. And now we've counted everything. And now we count the right-hand side. Start with the tins. How many are there? There are 3. How many nitrogens are there? 1. How many oxygens are there? Yeah, 18. 4 times 4 is 16, plus these 2 is 18. Oh, it's fun to hear gears turning and light bulbs coming on. I love it. K, how many are there?
1.
There's only 1. And phosphoruses, how many are there? There's 1 inside the bracket, but I've got a 4 outside. 1 times 4 is 4. Yes, it is. And it's going to get better. By better, I mean more annoying. So here we go. I'll zoom in so it's easier to see. So you can see we've got problems. The tins are not balanced, the nitrogens aren't balanced, the oxygen, nothing is balanced. And so we're going to start on the left and we're going to work our way right, and we're going to tweak coefficients until everything is happy. What could I put in front of the tin 4 nitrate, that's what this is called, to balance the tins? First, we're just doing one element at a time. What could I put here to balance the tins? A 3. Okay, so let's go ahead and do that. Every time you add a coefficient, you have to recount everything on the side you changed. So now I'm going to cross out that 1, and I'm going to change that number to a 3. You betcha. But what else have we changed? We've changed the number of nitrogens. How many nitrogens are there now? 1 times 4 is 4, times 3 is 12. You're multiplying it all the way out. Subscript times coefficient. And then you have to add to, whatever's in the other one if you have the same element in multiple spots. Like the oxygens, the next question is how many oxygens are there? Well, this one has 2 times 4 is 8 times 3 is 24 plus 4 . Yeah, you never multiply these numbers down here. These numbers that I list down here on the bottom are just a count of what's going on above. So what did I say that was? 2 times 4 is 8, times 3 is 24, plus 4 is 28. Are we cool with what I've done? Okay. The K's have not changed. The P's have not changed. My tins are balanced. That's great. We've done something. Okay, let's move to the ends. What could I put in front of, so that I've got 12 on the left, I've got 1 on the right, so what could I put in front here so that this thing, the KNO2, potassium nitrate, gives me the same number of nitrogens as is on the left-hand side? Yes. If I put a 12 here, 12 times 1 is 12. So I recount what's there. And now I have to go back and I have to change both the potassiums and the oxygens. Potassiums are the easier one. They only show up right there. How many potassiums do I have total? On the right-hand side? Not anymore. By putting a 12 out front, I now have 12 potassiums. 12 times 1. And now the oxygens. How many oxygens do I have on the right-hand side total? 12 times 2 is 24, plus the 16 from over here. 24 and 16 is? You betcha. 40. You are welcome to use a calculator. I do not expect you to do this in your head. Oh, nope, that's not the right. I changed the wrong one. That's 12. The oxygen becomes 40. 12 times 2 is 24. 4 times 4 is 16. 16 and 24 is 40 oxygens. I accidentally put the 40 next to the K, not the O. I just changed it. It's next to the O. By putting a 12 here, yeah. Putting the 12 here gives me the 12 potassiums. I now have 40 oxygens on the right-hand side. Now, that pro tip I gave you, oxygen always last. Because oxygen shows up literally everywhere, do it last. Because if you balance everything else, sometimes the oxygen actually gets balanced for us. So we're going to skip the O's and we're going to go to the K's. I've got 12 on the right-hand side. I've got 3 on the left-hand side. What could I put right here so that I could balance out the K's? Someone said put a, Muller, was that you? Muller, you're right. If I toss a 4 here, 4 groups of 3 Ks is 12 Ks. But now I've got to go count everything I've just changed. I changed the potassiums. So I changed the phosphoruses as well. How many phosphoruses do I have on the left-hand side now? I've got 4 phosphoruses on the left-hand side. And now how much oxygen do I have on the left-hand side? Total. Let's do each piece. 4 times 4 is 16. 2 times 4 is 8 plus 4. 2 times 4 is 8 times 3 is 24. 24 and 16 is 40. And now look what we've done. By focusing on everything else, my tins are balanced, my nitrogens are balanced, my oxygens are balanced, my Ks are balanced, my potassiums are balanced, my phosphoruses are balanced, we're done. It's tedious. You're going to get faster. Every one of you is saying, I don't think I can do it on my, you will. You will. You're going to do it. Sorry? We are. It's done. It's over. Because it's not needed. Because it gives me 3 tins, but I already have 3 tins on the left-hand side. It provides me with the 4 phosphoruses, but I have 4 phosphoruses on the left-hand side. So when there is a blank there, if the blank is bothering you and everything is balanced, toss a 1 there. And when I provide you with an answer key, because I'm going to, I'm not going to provide you with the entire question. How I would provide you with an answer key for a question like number 2 is I would say this. The answer is 3, 4, 12, 1. And that from left to right is the list of coefficients on each compound. So this is how you'll see the answer key. This is what it means. Let's do another interesting one. Is this one that's going to be interesting? Yeah, this is a great one. Okay, number 3, here we go. Same procedure, but there's going to be an extra bonus little snaggle in this one. So I'm going to force these spaces here again. I've got 3 elements. It looks like it's going to be easy. The 3 elements are C, H, and O. I'm going to list them in the same order on both sides. And now we count. How many carbons, hydrogens, and oxygens are there on the left-hand side? Oh, sorry, I'll slow down.
2, 6, 2.
Yes. There are 2. There are 6. And there are 2. As I try and slow down. You betcha. So the left-hand side, there's 2 carbons, 6 hydrogen, 2 oxygen. On the right-hand side, there's 1, 2, and 3. So we're going to start left to right. When we end up with hydrogen and oxygen, we are going to leave hydrogen for the absolute end. Here we go. So I need to balance the carbons. What could I do to the right-hand side to balance the carbons? Times what by 2? If I put a 2 in front of the CO2, that's going to give me 2 carbons. But what else does it do? 4 oxygens here, but there's another one over here, so 5 total. Okay, so now, the oxygens are on, oh, wait a second. Did I give you the wrong tip before? Yeah, I totally did. This purple line that I wrote, change that H2 and O. I got it backwards, my apologies. Oxygen, absolute last. My apologies. Change that H2 and O in that purple line right there. Easy fix, profound implications. Okay, when you're ready, flip back. So we're going to hold off on the oxygens for a sec. We're going to look at the hydrogens. I've got 6 hydrogens here. So what could I do to the right-hand side to give me 6 hydrogens? I could toss a 3 in front of the H2O. You're always multiplying when you throw a coefficient down there. So I've now got 3 times 2, 6 hydrogens. How many oxygens do I have total? Now, how many do I have on this whole side of oxygens total? 2 times 2 is? Plus 3 times 1? 3 times 1 is 1. 4 plus 3 is? 7. Okay, so that last tip that I had you, okay, and now look at what's going on here. Is there any coefficient I could add in front of the oxygen to give me 7 of them? No. There is no number, no whole number, you're going to multiply by 2 to give you 7. And so that last tip that I gave you on the bottom of the previous page said, if an odd number of oxygens is giving you grief, double everything that you've already done. So there is an odd number of oxygens that's giving us grief. All we've done is messed with these 2 coefficients, and so we're going to double both of them. The 2 is going to become a 4. The 3 is going to become a 6. And now we're going to recount what we've got on the right-hand side. How many carbons are there now on the right-hand side? There is now 4 of them. How many hydrogens now are on the right-hand side? There are 12. 6 times 2 is 12. And how many oxygens are there now on the right-hand side? 14. 8 here, 6 here. 14 is an even number. That's beautiful. Is there a number I can throw in front of the O2s to give me 14 of them? Yeah, there is. And now I just have to go back and finish the carbons, and well, finish the carbons and the hydrogens, but that's going to be done in one step. What number could I throw in front of the C2H6 to balance a 2? Because for the carbons, 2 times 2 is 4, and for the hydrogens, 2 times 6 is, and we're done. So this one is an exercise in that last tip. When an odd number of oxygen is giving you grief, double everything you've already done. Okay. Number 4. Yeah, but math is science's annoying younger brother. You just never know when he's going to show up. It's supposed to be a science. Yeah, math will show up in everywhere in science. Biology, chemistry, physics, earth science, you just never know when. Okay, here we go. Let's list everything we've got. I've got some NAs, I've got some Ns, I've got some Os, and I've got some PBs. Remember, O shows up in 2 spots. Do not list it twice. Now on the right-hand side, I've got the same list. I'm going to write it in the same order, Na, NO, and PB. And when you're ready, start counting. How many NAs on the left? How many N's on the left? How many O's on the left? How many PBs? Cool. On the right, how many NAs? How many N's? How many O's? 7. How many PBs? 1. Okay, so we're going to work left to right. First thing we're going to tackle is the NAs. What could I toss in front of the sodium nitrate to balance out the sodiums? We toss a 2 there. And now we recount. I now have 2 sodiums. How many nitrogens do I have? 2. How many oxygens do I have? Yeah, I got 7. 2 times 3 is 6, plus the 1 over here is 7. And oh, wouldn't you look? It's done. Yeah, isn't it magical? It's nice when they work out so easy. Okay, one more example and then you're on your own. Boom, 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 boom. Here we go. Yes, we can do it. You can do it. I believe in you. I have great faith. List everything you've got, left to right. I've got H's, I've got S's, I've got O's, I've got B's, and that's everything. At this stage, list the individual atoms. H, S, O, and B. Done. Those are the unique atoms on the left-hand side there. The list on the right-hand side has to be the same, law of conservation of mass. It shows up on one side, it has to show up on the other. So H, S, O, B. Which almost sounds like we're cursing. And now we count. How many hydrogens on the left? How many hydrogens on the left? There are 5. I have 2 hydrogens here, and I have 3 more over here. You add, because there's a plus sign in between them. 2 plus 3 is 5. How many S's? There's 1. How many O's? 7. How many B's? Okay, right-hand side. How many H's? How many S's? How many O's? 13. How many B's? That list is correct from those ladies in the back. Does anyone have any questions about where any of those numbers came from? Yes, Sarah. The S's on the right-hand side? Okay. So the reason that there's 3 S's is because inside that SO4, when there's no subscript there, it's a 1. And there's 3 groups of it. So 3 groups of 1 is 3. Then the oxygens is the same. 3 times 4 is 12, plus this one over here is 13. Any other comments, questions, concerns? Okay, let's keep going. So we're going to start left to right. But I did say to leave hydrogen and oxygen to the end. So if we're starting from the left and we're leaving hydrogen and oxygen to the end, the first thing we're going to balance is the sulfurs. The S's. What could I do on the left-hand side to give me the same number of sulfurs on both sides? Put a 3 over here. Putting a 3 over here is going to give me 3 sulfurs, but what else is it going to do? Yeah, it's changing H and it's changing O. So how many H's do I have here now? 3 times 2 is 6, plus the 3 coming over here is 9. Those are the H's. And now what about the O's? 3 times 4 is 12, but I've got 3 more over here. So 15 total. Yeah, and the B is not yet changed. What do you mean? Oh, you're talking about adding. I haven't jumped yet anywhere. Yes, you're right. That is going to be our next step. But I'm just trying to make sure I don't leave anybody behind. O and H we leave to the end. So let's go and deal with the B. What could I put here to give me 2 of them? A 2. That's going to change my B's, but it's also going to go back and now change my O's and H's. How many H's do I have now on the left-hand side? 3 times 2 is 6. 3 times 2 is 6. 6 plus 6 is, I've got 6 hydrogens here, 6 hydrogens here. Evelyn, you cool with why that happened? Hold on, we're not doing next yet. We're still talking about H's. No, these numbers down here, you do not add to these numbers that are down here. This is just a record of how many there are at each step we've done. So I crossed out the 9, and now I recount. Here I have 3 times 2 is 6. Here I've got 3 hydrogens times 2 is 6. So 6 hydrogens here and 6 hydrogens here gives me 12 total. We're adding them together here, not with these numbers that are down here at the bottom. So I've got 12 hydrogens. You're adding between the two reactants. Correct. Correct. Yes. That plus sign functions as the mathematical operator. If it's plus between the two, you add between the two. Absolutely. Okay, and now we still haven't changed the O's yet. How many oxygens are on the left-hand side now that we've put this 2 in front of the boron hydroxide? Yeah, 2 times 3 is 6 from here, plus the 3 times 4. So the 6 plus the 12 is 18. Yeah, don't do that. So now the sulfurs are balanced, the borons are balanced, and we've got O and H to do. We're going to balance the O's last. So let's do the hydrogens now. What could I do on the right-hand side right here to balance out my hydrogens? Toss a 6 there. Because 6 times 2 is 12, and there's nothing else to add. And now let's go count the O's. How many oxygens do I have on the right-hand side? 6 from the water and 12 right here. 6 plus 12 is 18, and my oxygens are done. The 2 times the 3. And we added those 2 together. And if you look at each element listed, they're all balanced. It's done. You wouldn't, when there is, it's just like in math. If there is nothing listed, it's assumed to be a 1, so you don't actually have to put it in here. But the way the key would be listed would be like this, 3216. The key will always, because I don't give you the whole equation when I give you the answer key. I will put that 1 in the list here, but it's the same as it not actually being written in the full-blown balanced equation. There are 4 coefficients, yeah. Yeah. Okay, that's the last one I'm going to do. Your turn to go play. This block ends at, is it 1:25? Is it 1:15? What time is it? Okay, cool. You got 20 minutes. Here's what I want you to do. There is a list here. The next 3 pages, it says easy, and then it says medium, and then it says hard. They are not all confusing, I assure you. Some of them are varying degrees of absolutely horrendous. Here is what I want you to do. I will tell you what I am actually assigning for homework practice, but 2 minutes before the bell goes. I want you to start with the easy 4 and just go. Do as many of them as you can. If you get done all 12, I likely won't assign anything beyond that. But if you don't get all 12, if you're stuck on some of the hard ones, I will shrink what I assign, if that makes any sense. So I would encourage you, I know you've got the space here. I would encourage you to move to the whiteboards. It makes it easier for me to see what you're doing. You getting up and around on the second last period on a Friday is also not a bad idea. But use this time. I'll float around. You've got 16 questions on your market set go. And I've got an answer key. If you want to check while you're going, let me know. Yeah, so then you just move zeros. Then you have to balance the way back into the yeses. So you've got an odd number of options that are giving you a problem. So hold on. You've got an odd number of options that are giving you a problem. My tip for dealing with that is to immediately do what? Double. So change that 1. Invisible 1 that's there? No. That'll be, in this case, that'll be the first step. Or you two do. You were very quiet while I was singing. Yeah. Okay. Okay, so this is that last tip. You've got an even number of options on the left-hand side. You've got an odd number on the right-hand side. So whenever there's an odd number of options and it's giving you a problem, double. Not everything, just what's giving you the issue. This is a example. So put it, so that's a 1. No, it's not. 4 plus 8 is what? 12. Addition to now you have 4 sulfur, 8. You have 4 here, and now you have 12. So what's the balance? We need 4, 12, 12. Right? Okay. Now, how many do you have here?
How did you get into the show? If this is NG, it should be two of NG and two of.
And by all means, especially while you guys are practicing, don't do it on your own. Work together. All up on the board. Discuss these things.
Yeah, one of them.
As much as possible, do not work on your own.
Then bounce on your own.
This is not balanced.
Yeah.
Back here. 2 times 2 is? 2 times 2 is? 2 times 2 is? 4. 4 options is 8. So, should you have put that 2 there? No. Because don't put that 2 there. Now you've got 2 options here, 4 options here, 2 options here. That would give you 6. And you should have had 6 over here. Just like you're having fun. You got your L? So you have to wait months. Okay. You don't need to, I can read it upside down. So that you can actually read it.
Why?
Only if it's causing you problems. Only if it gives you grief. Sometimes you can end with an odd number, and that's okay. It's only if it's not balanceable because of the others. Okay, so the first thing you're going to notice, so I was talking about, you've got groups of 3 oxygens here, but you've only got 2s and 2s over here. You've got an even number here, you've got an odd number here, and it's not possible to write an even number of things and get an odd number. Because the sulfur is already balanced between the 3 oxygens, the oxygen odd number is the problem. So you want to put a number, you want to double whatever number is currently in front of the odd number box. In this case, that's going to be reversed. And now recount everything. But by putting a 2 in, you also change the result. And now you go back here. Oxygens, always last. So let's go back and look at the result. I have 2 here, I got 1 here. So you put up 3 here. 2. And now, two oxygens. How many oxygens do you have here? She's looking at the result. You have 2 plus these 2. 6.
Yeah.
Plus. What was the first step? Sorry? They are. But all y'all are strong, independent women. I'm going to let you suffer until you ask for help. I will not force my help. I respect the strong, independent women. Start again. Yeah, that's in the game. Which brook is this? This is brook. Okay.
Oh, that's it.
That makes sense for me. However,
Hey, see, they figured it out.
Yeah, you got it right. Yes, actually, absolutely. No, it's not 1 because it's only 1, so 1 times 2, that's the coefficient.
You have the same
So 1 plus that is 2. And over here, it's already 2. But you're not minding that. But if you start getting this, it will yeah, bro. Is there any coefficient before 2? I mean, before 8? No, so there's only some years we need 2, so it's 2. So 2 and 2 balance, 2 and 2 balance. No, it will not be the same. MG, this 2 only applies to MG. But this one though, it applies to both MG and PI. That's what makes this become 2. No, sorry, the MG, like 2 MgO. Yeah. This is why this is you're really doing that.
Now you have to go back and do this. By putting a 2 there. Okay.
You got this, bro?
Okay, gentlemen in the middle, how are we? Go ahead, so you want me to check?
Sure. I got 212. 212 again. 132 and 221.
These two make sense? Always plus hydrogen. So you have two nitrogens. Only on one. Two on this side. Now recount that. Hold on, how many here? Two up front. Now left. What do you put there? 6 axes. Okay, ladies and gentlemen, your homework for the weekend, I want you to get the easy and medium ones attempted. 8 questions there. Bell's going to go in a minute and a half. When it goes, you may also go. Have a great weekend. Try those first 8. I will leave the hard ones for us to play with together on Monday. How are you two doing? Are you doing okay? Are you doing? You look really bored, so I'm assuming you're good.
No,
Does
the
it make
next
sense?
team. Some important next team.
Okay.
If we actually check the actually
Okay. Have a good weekend, guys. Try those first 8, and I'll see you Monday. No. Why? No. Why would you do that? You have the stuff that we did yesterday. It's the no pack.
Yeah.
Clearly, you did not watch the video from the lesson.
I'll watch it tonight.
I'll show you. Have there was nothing new that was handed out yesterday. We just did more balancing. Oh, wait a sec. Yes. Or was it the lab stuff that we did yesterday? Pull out your notes. It was the day before. It was just balancing stuff.
Okay.
So yes, you missed a bit of a lesson. We'll get you caught up. But definitely watch that video. Okay. I think you got it now.
But you can really unsend it. You should bring up my name. Say this. Yeah. No. Actually, sure, go for it.
Okay. I can delete you. It's gonna be tomorrow. Yo, Mr. K. I do.
She's finishing up a test.
Unacceptable. Of course. Wow. It's not going to be the end of the world. She's not going to enjoy it.